Hello everyone and welcome to the Game Engine programming series where we write the game engine from scratch. In the previous episode, we wrote some of the functionality that we need in the geometry asset class in order to further process the generated or imported meshes. Starting with this video, we'll create a new dialog window that will allow us to tell the content tools what kind of primitive mesh we would like to generate and what settings should be used for that. Let's start with a couple of improvements and fixes, as we do every now and then, so they don't pile up. The first one that I would like to do is this typo that I made here. It should be skeleton. And in geometry CPP, in the last function that we wrote, pack data, I would like to just add a check at the end to make sure that the amount of bytes that we have written to this buffer is the same as the scene size. And the next one is a mistake that I made in EngineDLL in Entity API, where I copied the contents of this local variable for rotation quaternion that we just calculated here to the return value of this function. But the size that I'm giving it is wrong because this rotation member field is just 3 floating point values, whereas the rotation quaternion has 4 components. So this one really should be the size of info rotation, which is 16 bytes. Thank you again, Scott, for catching this one, because it would have taken me quite some time to figure out what was going wrong here, so thank you for saving me that time. Next, I'd like to set project dependencies. And by project dependencies, I mean that the engine project should be built before EngineDLL and engine test, because these two projects are linking to engine library statically. So right now, if I would clean this solution and then rebuild it again, you could get an error. Cannot open file engine lib. So until now, I just hit rebuild again. But to make it so that we just built a solution and everything is fine, I will set the dependencies. And it doesn't matter for the other ones. For example, Primal Editor loads these DLLs dynamically, so it wouldn't matter which one is built first. All that matters is that they are there at runtime. But if you want to link to something statically, then it should of course be built before anything else. Okay, so let's go to the world editor and add a button in there so that we can open a window that would let us choose what kind of primitive mesh we want to generate and what their settings should be. Now, as you can see, I'm getting an error here. There's an exception at design time. Although the solution built without any problem and I can even run it, Visual Studio Designer has a problem. And that one has got to do with on render surface view loaded. I'm not sure how this happened because it wasn't there before. And I did an update for Visual Studio, so maybe that's the cause of it. But there is also a solution to this. If we look at the render surface view, it's about this function, and something here causes that error. And I think I know what's going on. The designer can't do this. There's probably not a window parent for whatever is in here. And to check that, I could just comment this part out and build again. And going back here, you see that everything works fine. So that's really the problem. And it's okay because this is something that I would like to get rid of anyway. Right now, you can see that we have 2 message handlers here for Windows messages. And we did this because we couldn't detect mouse left button state when we were resizing the entire window. And now I'm going to show you another method to do it more properly. First, let's go to render surface host. And here you can see that we ignore resizing while left mouse button is down. First, let's have a private field. So this is one of those constants that is defined in Windows header. Next, we need to import a function for checking keyboard and mouse button states. Now, instead of using this line, all we have to do is to call this function with this argument. And if you would look this up in the documentation to see what it returns when a key is down, then we can see that it sets the most significant bit if the key is down. And when we are returning an int, the most significant bit is interpreted as the sign of that value. And therefore, that means that if the most significant bit is set, we get a negative value. And that's why we check here that the return value is less than 0. And the next thing that we need to do to get rid of these extra message handlers is to handle resize here. We know that this render surface host is an hwindow host, which in turn is a framework element. And the framework element has a size changed event, like any other control. So we can just attach an event handler to size changed event. And then we wouldn't need to have this public resize function anymore. So we can delete that one. Everything is handled internally now. And going back to render surface view, we don't need this hwindow message hook anymore. We don't need to handle this. I'm not deleting this one because we will need it later to detect keystrokes when we will use keyboard. So I'll keep it around for now, but the upside is now that we can get rid of this part. And also these fields aren't needed anymore. That made this a lot simpler. And let's see if it solved the problem with Visual Studio Designer. World Editor is okay now. All right. We can also try and set a breakpoint to see how often we get here. And as you can see, as I resize the entire window and let go of the mouse button, then it gets in here. Excellent. So we made our code a lot simpler and also got rid of a problem. So this was a detour from what I wanted to start working on in this video initially. And now I'm ready to add a button here to open a new window for us where we can decide what primitive mesh we want to generate and what their settings should be. All right, now we have a new button here, and when we click it, we should get a new window open. Here, all I would like to do is to open a new dialog window. So let's add a new dialog window that has this name, and I'll put that one in the content folder. Let's configure this window so that we can use it as a dialog window and not a regular window. So the first thing that we can do is to set its style to use the primal dialog style and give it a nice title. And we don't want this to be resizable, so resize mode is no resize. And then I'd like to have a border here with a drop down that would let me choose the type of primitive that I want to generate. And when I select one type, then it will show me the corresponding settings for that type of primitive. All right, so here is our combo box, and I'd like to add items to it that would represent each type of our primitive meshes. And therefore, I need to add an object data provider that converts our enumeration for primitive meshes that we have here to the names of combo box items. Okay, in order to be able to use this data provider with enums, I need to add a new namespace so that we can use the system dialog. And now I can use this to set the items in the combo box. And of course, we need to implement this selection changed, which I will do later, but for now it's just an empty function. And now you can see here that this window is opened and we can't resize it. But if we click on this combo box, then it should show us the primitive types, which it doesn't. So I probably made a mistake somewhere. So this one should be get values instead of get value. Because we set the selected index to 0, it selects automatically the first item in the enumeration. If I would change this to 2, for example, it would go to the third item. But we want to have plain on default, so I'll set it back to 0. And now you can see that we have all the items here. Next, I want to show the settings that belong to each one of these. So we will create a section for the settings of each type of primitive mesh. So the first one is the plane. All the settings for creating a plane will be in this stack panel, and we only make this stack panel visible when the plane type is selected. So we can put all the settings in the same grid and just show the one that is currently selected. So the first of the settings that we want to set is how many segments we have along the width and the depth of this plane. And I'd like to use a slider for that. And I used element binding to bind its value to the text box. So you can set the number of segments either by typing in this text box or using the slider. So this one is for the width, and we need to make one more for the length of the plane, which is just a copy paste of this. All right, now we can set the number of segments along the width and the length of the plane. And the next setting is the size of the plane. So to set the size, I'm going to use the ScalarBox. That's one of these controls that we made for setting vector values and scalar values. So I need to have a namespace for the utilities. And finally, I would like to add a save button so that we can save the plane to an asset file. Now the way that I would like to generate the geometry is by calling CreatePrimitveMesh function every time something changes here. So for example, if I set a new type of primitive mesh, then a new one should be generated. And if any of these settings change, then also a new geometry will be generated. So as you can see here, we have on slider value changed. So we can try and implement that. And we also need to implement something that will notify us whenever the value of a scalar box is changed. But right now we don't have such an event for a scalar box, so we need to implement that first. Going to the controls and scalar box, you can see that it inherits from number box. So we need to add a routed event to number box class, which will be raised when the value of the number box changes. The way we create a routed event is pretty similar to what we do for a dependency property, and that's by registering it. So we call this register routed event with the needed parameters, and then we also need to have an event with this name. And here we have the event that has the add and remove methods. When we attach handlers for this event, it will call these methods. It acts pretty much like a get and set. In fact, I think I could even do this, like we do for getters and setters. Okay, now that we have this routed event, we need to raise it whenever this value changes. And therefore, we are going to add a new callback function here, where we register this value property that will call a static function in this class to tell us that a value has been changed. Now every time that the value changes, this method is called and then we raise the event. And everyone who has attached some event handler to this event will receive a notification. And now we can go back to our primitive mesh dialog and then we can use this event. Notice that we are not differentiating between any of these scalar boxes for width and length, and also no differentiating between the sliders, because all we do is just to trigger a value changed event and then generate the geometry. So it doesn't matter who sends what event. So here, for example, all we do is just call UpdatePrimitive. And UpdatePrimitive is the method that actually calls CreatePrimitveMesh function. So one thing that we need to be aware of is that when this control is loaded, then this combo box will call selection changed event handler, even though we haven't set any value for it or any valid data. So we need to check whether this control or this window has been initialized before we can use this function. So if this window is not initialized, then we just return. Here we create an instance of primitive init info, which has this information in it, and then we set the primitive mesh type that we want to create. And other than that, we need to fill in the number of segments and the size. For the plane, we don't use the level of details for now, so we don't need to set this one. But we do set the number of segments for the width and the length and the size of the plane. Here I use the code snippet that will generate this switch for me, so I don't have to type all the options, which is pretty handy. So if we have a plane, we just fill in the remaining settings. So I'd like to get the value of the slider. And because the plane is on the XZ plane, I'll need to fill in the X segment and the Z segment. The Y segment is ignored. And I mistakenly called the slider for the length Y slider, and it should be Z slider. So I'm going to correct that mistake. It doesn't really matter, but it's more clear if I do it like this. So we have the number of segments here, which is an integer, and the value that comes from the slider is a double, so we need to cast it. Next is the size of the plane. Again, we set the x component and the z component because the plane is on the xz axis. In this case, because we are using that scalar box, we need to get its value. The value property of this scalar box is a string, so we need to parse that. And for that, I'm going to write a method that we can call to convert the strings for us to a floating point value. This method will take a scalar box and a minimum value and parse the value of the scalar box to a result and return the maximum of those two values. So we can set a minimum for this value because the size shouldn't be negative. So here I'll call this method maybe something like this. I'm imagining that our units is one floating point unit for 1 meter in the 3D world, and the smallest object that we want to construct is 1 millimeter. Of course, in the transform of this object, we can make it bigger or smaller, but the baked in vertex coordinates will have these dimensions. Okay, and after we filled in all the settings, we can call CreatePrimitveMesh function. Remember that this function expects a geometry asset class, so we need to give it a geometry. And the initialization info. And now we have everything that we need to actually generate a plane. So if we did everything correctly in the last episode and this video, then this CreatePrimitveMesh will give us a valid geometry that contains a plane. So one thing that I actually forgot to do is to implement this event handler. And we also want to update mesh primitive or generate one when we load this window. So there is already an object there waiting for us. So now we can do different things. Now that we have this geometry, we can try and save it to a file. But before doing that, I would actually like to see what's in there so we can check whether the geometry that we created is actually valid. And of course, we could go in the data structures and examine vertices in the debugger and see if there would be 4 vertices in there when we generate a plane with 1 segment. But it would be easier and also more fun to actually see what geometry we generated. Of course, we don't have a graphics renderer yet, but fortunately, we can have a 3D viewer in WPF that we can use to show basic properties of a geometry, like what it looks like, and display it with the basic lighting and textures. But that will have to wait until the next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!